Hello everyone and welcome back to day 13 of 30 minutes of problem solving a day. Holy moly, 13 is actually pretty insane. 13 is also a very epic number. So, whoops, I still have like half of my OBS showing, but there you go. And we're going to continue where we left off on the 2021 AIME 2. It's going to be very epic. My throat still hurts. I don't know why. It's crazy. But we'll just do our best. Okay, I'm sorry if I'm not super energetic. But we will start off where we left off on problem 11. Let's do it. Okay. So, we already read the question, but basically what it's saying is there's four perfectly logical students. Originally, they don't know what S is, but after they all say no, like if none of them could tell what it is, then they all know what it is. So, basically what we figured out is like each of them basically have to have two possible ranges at work, right? Like let's just say I got like 65, right? Then the options I have that like what the range could be is 65, 66, 67, 68. 64, 65, 66, 67, and 66. Wait, what? Yeah, okay, that's right. Bruh. And we got 63, 64, 65, 66, and we got 62, 63, 64, 65. Okay, so essentially, like just looking at this, the only one that works is actually this one, right? Because this one has actually no, that doesn't even work. So the only one that works is actually this one, right? Because this is the only one that has both the divisible by 6 and divisible by 7. So that is why if you get 65, you already know what it is. So that's not going to work. Okay. Then, if you get like, an example of one that doesn't work, that like you would not know, is 63, right? Then you could get like 64, 65, 66, you could get, so that's one option, right? You get a divisible by 6 and you got a divisible by 7. And then the other option is like 67, 60, 61, 62, 63, right? Then you have a divisible by 7 and you have a divisible by 6, right? So either of those could work, so this guy doesn't know what S is. But like for either of these, right, then like for either of these you could basically say like what? A different number in S deduce what S is, okay. Yeah, none of them are able to. But like the problem with this one is like if you got 61, then you know it has to be 60, 61, 62, 63, right? Because there's no other one that works. Okay, is there? It'd be 3 and then 4. No, that wouldn't even work because you can't get another multiple of 7 anywhere close. Huh. Yeah, like the problem with this is like multiples of 7, they only happen like every 7, right? And like these consecutive ranges can only range for 3, right? So how do you even do that? 4 consecutive, right? Okay. 2-digit positive integers, and some number was divisible by 6, and a different number is divisible by 7, and a different number is given to each. So they know it's consecutive, yeah, okay. Well, okay, so what we had last time, okay, let's just go through it, right? So, got 12, 12, 18, and then 14, right? So, if you can't get 14 and 18 in the same thing, so that's not going to work. Divisible by 6, yeah, okay. 12, 14 would work, but then there's no other one that's even remotely close. So you got 21. What about 21, 24? Then essentially, if you got 21, it could either be 21 through 24, or it could be 21 through 18. But then, if you got like 20, then you know that it's 21 through 18, right? Yeah, I don't really get the logic here, right? Because just guaranteed, there's one guy who might not be able to determine it, right? Because it's like two multiples of 6 on either side, right? But there's no way to get like more than two multiples of 6, right? So you either go get the one on your left or you get the one on your right, but you can't get both. And then if you move over one, there's only going to be one multiple of 6 there. So you can't even get too often for that. Huh. Yeah, like if you got 15, then it has to be 12, 4, 13, 14, 15, right? Because you can't get like 15, 16, 17, 18. Because that would not have a multiple of 7 in it. What? What? I feel like, okay, dude, watch it be like a troll and it says 0 because it's not possible. Although I feel like that's kind of troll. Uh, I mean, it's kind of implying that it's possible. What? I feel like my logic is not wrong, right? Because like the one guy who like if you stretch him as much as possible, he could get like two. He could get two things that I have like one multiple six or another, right? But then you can't get like. But then if you move him over one, then that guy over one is gonna miss one of the multiple of six, right? So he would know which one it is. Huh. What? What else could it be? I don't really get it. Okay. So if you got like 61. Okay, you know what? Let's just write it out again. 6, 12, 18. Well, 6 is not really an option. 12, 18, 24, 30, 36, 42, 48, 54, 60, 66. I feel like this should be doable. Okay, well, I'm not going to spend too much time on it. Let's just see how long we're spending. Okay, let's just say if it goes to 15 minutes, we'll move on. So we got like 60, 72, 84, or 78. 84 doesn't work. Also, 42 doesn't work. Um, yeah, okay. Uh, and it would be 90, or sorry, 8, wait, what? 84, plus 7, or sorry, yeah, 90 is divisible by 6. Okay, 96, that's it. And then we have 7, 14, 7 I guess doesn't work. 21, 28, uh, 35, 49, 56, what else? 63, 70, 77, 84, nope, 91 and 98. Okay. I still do not get like just logically what could be an example of where none of them know what it could possibly be. Because one of them for sure is it does have one range in their possible ranges, right? Let's see. Some number, okay, set of 4 integers. Are they negative maybe? I don't know. Oh, they're positive, it says. Uh, okay, let's just say you got like our range is 12, 13, 11, 12, 13, 14. Well, this guy definitely knows it's 11, 12, 13, 14 because like there's nothing on his left side. Okay. Then what about 12, 13, 14, 15? Yeah, okay, that doesn't work. 14 or 15, 16, 17, 18. What about that? Well then this guy could either be 12, 13, 14, 15, right? Or this, right? But then this guy, no, but that's not, doesn't have any divisible by 7 here, so that doesn't work. 18, 19, 20, 21. So if you got 21, you could either be 24 or 14 doesn't work. If you got 19, you know it's this, right? What else could it be? If you got 19, how can you not deduce what it is? Oh, maybe it does have to do with that, like, cutting out the 84, maybe? I don't know. Well, no, the 84 doesn't really make sense. Oh, that's a even bigger gap, so that's not going to help. Maybe one of the edges helps? I don't know. I mean, the edges would just help them deduce it, right? I don't really get it. Let's see. So, you could get like, oh, okay. So, I guess, no, but you can't really get another multiple of 7, right? Yeah, I still don't get the logic here. Okay, well, let's see. Um, 24, 21 through 24. Okay, no. 24 to 28. Nope. 28 to 30. Okay. I was kind of trolling. I kind of get it now. So essentially, what the idea is, like, if you have like 20, let's just say you have 29, or let's see, 28, 29, 30, right? You can either have like, if you got any of these, your answer can either be 27, 28, 29, 30, or it could be 28, 29, 30, 31. Okay, so that's the uncertainty we actually want to look for, not the other type that I was thinking of. But we essentially need both of these guys to have that uncertainty, right? Because they don't have any uncertainty in terms of shifting it, right? But they need to be. So how far away are they? 4? Okay, well that changes things. Well, okay, maybe they're like. Well, let's see. Maybe okay. Let's say if they're like right next to each other, right? We got like um. Where's one that where they're right next to each other? 35 and 36, right? Then essentially, if you got 34, your answer could either be 34, 35, 36, or it could be 33, 34, 35, 36. Then if you got 37 or 37, yeah, then you could get like uh well, if you got 35, 36, 37, yeah, then the 37 guy could either be these two or what? Yeah, okay, so it could either be this or it could be like 1 over, right? Um and then these guys don't actually have any other options, so. Wait, but doesn't the guy who have the multiple of 6 know exactly what it is, though? Right, because if you have a multiple of 6, right, let's just say you have 18. Okay. Oh, I keep forgetting, you can shift it over, that's the thing. So in this case, nobody knows, right? Because this guy could, like, have, it could be 34, 35, 36, it could be 33, 34, 35. Oh, okay, 36, okay. That makes a lot more sense. Okay, so we're getting close. How much time has we spent? Okay, 14. Okay, I think we can get it. So, essentially we got like 35, 36, 37. Could anybody figure it out? So this guy definitely can't, right? Because it could either be this 4 or it could be the next 4, right? Then this guy can't figure it out, right? Because then you could have, you could either have 35, 36, 37, 38, you could have 30, blah, you could have anything. You could have this guy, could have a lot of different things. But then once they all say no, Is there anything else that works like this? Are there any other ones that are different by 1? Why can't 9091 work then? Oh, sum of possible values. Okay, okay. So let's just make sure that if it's a difference of 2, it doesn't work. So if you have 28 and 30, right? Then essentially you have 29, 31, or you have, okay, so let's say it was 30, then you have 2 options, right? Okay, if it's 29, you still have 2 options. If you had 31, okay, if you had 31, then there's only 1 option, so this guy would know. Okay, so essentially, anytime there's a difference of 1, you actually know. So we got 9091, that's good. Uh, and essentially you need to give them, yeah, you got to do it like that. So essentially, yeah, I just don't want to miss one. Yeah, okay, that should be good. So essentially, what that means is that you got 9091, which means your maximum could either be, okay, well, only if you do it like this. That's the only way it would work. So you got 92. What else do we got? 98, no. 77. Uh, oh, 77, 78 works. Okay. So 79, okay. We got 70, 70, okay, what? So 77, 91, 98, no. 70, no. 63, no. 56, no. 49, yes. So 40, so 50, okay. Uh, 35, yes. So that's 37, okay. 30, 28, no. 21, no. 14, no. Okay, so we just sum these together, we should get our answer. 92, 79, 171, 171 plus 50, 221, 220, 258, okay. And that should be your answer. Let's check it. Hopefully that's right. That was kind of cool, but I keep, okay, yeah, it is. All right, epic, let's go. All right, problem number 12. That actually took us exactly 15 minutes, right? Yeah, okay, a little bit more. 1729, that's a nice number. Okay, problem number 12. A convex quadrilateral has area 30 and side length 5, 6, 9, 7 in that order. And you essentially want the acute angle, okay? Bruh. So, got 5, 6, 9, 7. Okay. So you got 6, 5, 9, 7, and we want area is 30, okay? Got your diagonals, epic diagonals. Dude, why am I so bad at drawing to scale? It's actually so hard. Okay, and then you got theta. Okay, well I didn't really. Which one's the cute one? Okay, that one seems the cute. Seems legit. Okay. Uh, what can we do to find the area? 180 minus theta. Okay. Convex. Oh, it's convex. Does that help at all? Does it help? I don't know. Let's see. Um, maybe, just maybe. What? Oh God. Okay. Well, okay. Basically, convex means that this is convex. Okay, and then this. Okay, so that would be like. So the biggest area for a 9 and 7 triangle is like 63 over 2, right? And then the maximum for this is 30 over 2, it is 15. And essentially, we want these to be also convex, right? How do you have a convex? Okay, well, no, what? I'm trolling. This is like literally, okay, so they don't need to be convex angles necessarily. Um, but what do we know? Okay, basically, if you fix the diagonal, you basically fix like the area, right? So let's say it's x, right? Then you're okay. Well, the area is kind of nasty if you try to do that. Um, okay, let's just say this is theta, maybe. Then you can use like law of cosine to find this, and then do log cosines again to find that. Okay, let's try that. So got 49 plus 81 minus 2 times 7 times 9 cosine theta, right? Is equal to x squared. Okay. And then we also have x squared is equal to theta prime. Okay, theta. Okay, let's do theta 1 and theta 2. Theta 1. X squared is equal to 25 plus 36 minus 2 times 5 times 6 cosine theta 2 is equal to x squared. Alright. Oh, I already wrote x squared, so that's fine. And essentially, if we set them equal to each other, we can find cosine theta 1 in terms of cosine theta 2, right? I mean, it's not going to be pretty, but we could try it. Do these sum to the same thing? Oh, well, no, they're opposite sides. Oh, wait, 6 and 9 and 7 and 5, did that help? No, what? That's definitely smaller. Yeah, okay. So 9 should pair with 5 if we wanted it to square nicely. Huh. Okay, well, whatever. You got 61 over here. To cancel, you got like 69 minus, what? 126 cosine theta 1, minus is equal to negative, 60 cosine theta 2. Okay. Which seems pretty useless. I don't really get the point of that. But we also know that the area, we know like 30 sine theta 2 plus 63 sine theta 1 is equal to 60. Alright. And we want the diagonals though. How do you find the diagonals, bro? I mean, ideally we find like the area in terms of this angle, but I don't think there's an easy way to do that, right? Yeah, how do you, okay, I'm not sure how to do that nicely. I feel like this might be nice to solve somehow, but not sure. Okay, you know what? I feel like I might not be able to get this one. So why don't we just try problem number 13? I have no idea where to start with that one. We could look back at the answer the day after. We could do that on the last day, just review everything we got wrong, right? Yeah, I think that's a good idea. So let's just look at the rest. Okay, problem number 13, find the least positive integer n for which n 2 to the n plus 5 to the n minus n is a multiple of 1000. Okay. So, let's just try it for a small integer and see what happens. So, you get like 2 plus 5 minus 1 gives you 6. Well, we should probably do something that actually gives you something above 1000. Well, that doesn't even help, does it? Okay, so essentially we needed to be 0 mod 125 and 0 mod 8, right? Whoops, 0 mod 8. 125, 8. Okay. So, like by Chinese remainder theorem, this is guaranteed to be 0 mod 1000. Okay. And, well, I mean, it's kind of obvious, but essentially, you could, well, we're assuming that n is greater than 3, and n is greater than 5, so, I mean, n is greater than 3, yeah. So, then we could basically say 5 to the n minus n is divisible by 8. And also we need 125 to divide 2 to the n minus n. Okay. So how do we do that? That is the question, bruh. Okay. So, well, let's see the pattern if there is one. So you basically have 5 to the 1 is 5, then 25 is 1, then 5, then 1, then 5. Right? Right? Am I trolling? Okay. So, when you have an even, okay, let's see. 625 is 624, what? 624 over 8. That should be 1, right? Wait. So 525, you square that, that should also be 1. So that should be 8, 6, 7, 7, 6, 4. Yeah, okay. So that is right. And essentially we we have that even powers give you mod 1 and odd powers give you 5, right? So essentially we want 5 plus 8n, or 5 plus 8n, yeah, because you want it to be divisible by, so 5 plus 8k works for n, right? Because that's always going to be odd, that'll only give you 5, and then you also want, like, plus 8k so that the subtraction actually is divisible by that. Or if you want an even option, right, you got 1s, then you need 1 plus, okay, that's just not possible though. Because if n is even, then like this is going to be odd, and odd minus even is never going to be divisible by 8, so that's good. Okay, so we got like 5 plus 8k, seems legit. Then what about here? We got 2, 4, 8, this is going to be a lot harder. 16, 32, 64, 128, so 3, 6. Okay, well this is going to go forever, right? Well, okay, so, huh. Well, I was kind of trolling here, but like the idea is like if n is even and it's like odd mod 8. No, I'm not trolling. That's right. But yeah, okay. So yeah. But this case is a little bit harder because there's so many different options here. I mean, I guess we kind of narrowed it down, right? We could try every single 3-digit, like 5 plus 8, like 5 mod 8k. I mean 5 mod 8, but that would take forever. It could be even also because that doesn't mean anything. Okay. Uh, 3, 6, 12. I mean, I doubt it's gonna repeat anytime soon, but we could just do it for fun. 192 minus 25 is 767. Okay. And then that goes to 120 or 134. Right? Yeah, okay. And then 134 becomes 9, right? Okay, well that just repeats again. Okay, that's kind of massive. I mean, not repeat, it's just big. Let's see, what else can we do? Uh, not sure actually. Okay, well we're approaching time, so I don't want to spend too much time on it. Maybe we could try the other ones, but I doubt. Like, if I was not able to solve 12, I probably won't be able to solve 14 or 15. So let's see. What else can we do? Huh. Maybe like, okay, so 1 doesn't work, 2 doesn't work, 3 doesn't work, and eventually you get like, this is 4, 5, 6, 7, okay. 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay, well essentially you just needed to wrap around again, otherwise it'll never work. Okay, let's see. So 1, 2, 3. You know what? We have time. Let's just write it out. Okay, so we got 5 plus 8k is n is congruent to 5 mod 8. That's good. And essentially we got 1, 2, 4, 8, 16, 32, 64. So that is 6, and then 6, and then or sorry, this starts from 0, and then this starts from 7. So then you get 3, 6, 12, 24, 48. So 7, 8, 9, 10, 11, 12, and then 13, you get 9. Or sorry, 13, you get 67. Then 14, you get 9, right? 7, 8, 9, 10, 11, 12, 13, 14. Okay. And then 15, 16, 17 is that. And then times 2, 144 minus 125. So 3, 1, 9, 1, okay, 19, all right. 14, 15, 16, 17. Oh, what? We missed it by 1. God dang it. So 19 is actually going to be, or 18 is actually going to be 19. Oh, rip. That's sad. Okay. So, you got 14, 15, 16, 17. Okay, let's just check. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. And then we could see, let's see. Maybe, huh. Well, okay, well, I guess that doesn't work then, so we'll keep going. That would be too easy, I guess, if we got that. So 38, uh, 60, 76, 1, 52, which is actually minus 125 is 27, okay. And then how much is that? 18, 19, 20, 21, okay. Yeah, not sure I see a pattern here. Let's see. 2 to the n minus n is divisible by 125. Huh. Maybe. Are they? Okay. I don't see anything nice here. Okay. Let's just keep going a little bit longer. How much time do we spend? Let's see. Okay, well, we're technically done. I'm just gonna list out a couple more. If I don't find it soon, we will call it a day. So what is, so they're like plus or times 2 is 216. 216 is how much? 216 minus 125. 1, 1, 10, 16. Wait, what? I know. 1, 1, 1, 9. Okay, so 91. All right. 21, 22, 23, 24. 182. 182 minus 125. 5, 7. Okay. 25. Yeah, okay. I don't really see anything here. So I guess we'll call it a day. I don't know. I mean, we didn't really get anywhere close, right? 7, 8. Okay, that's not really working. Okay. Yeah, none of these actually work so far. What we listed might take a while to actually get somewhere. Okay, let's just try one more time. So I mean a little bit more. So we got 114, 228. So what is 228 minus 125 is just 103. 103, 206 minus 125 is 18. Okay, 81 times 2 is 162 minus 25. And that does not look very helpful, but let's see. 125, 4, or 3, 7. Okay. Yeah, okay, this is not working, so we will call it a day then. I'm not sure how to solve those remaining problems, but we'll go over them next time, okay? But anyways, thank you guys so much for watching. As always, if you enjoyed the video, leave a like and subscribe for more. Let me know what other suggestions you guys have for video ideas. I hope you guys enjoyed the series. It'll be ending next time, but hope it was good while it lasted. Let me know if you have any feedback tomorrow. But other than that, I am done for today, so see you guys next time. Alright. Very epic.